Welcome to General Structures 2 and Lateral Forces, Lesson 3 quiz, question number 7. It says, select the correct statement about the cantilever truss shown above. And I have recreated that truss, and hopefully I did it correctly. So let's take a quick look about what we know about this truss before we look at any of the answers. And there's a few things you can do. You can take a look at zero force members for sure. Which ones are zero? Which this one stands out right here, this member. And I'm going to go ahead and call this a zero force member because if you look at it, you know that there's nothing that can resist. If you look at it, just cut that joint out. Look at it as you're taking it and looking at method of joints. You're going to have an X component, and both of these are both X only, and this is Y only, and therefore there's nothing to resist that. There's no equal and opposite force, so therefore that has to equal 0. Alright, so we do know that. And then we go over, and do we know any of these? Not necessarily. That's not necessarily a zero force member. I can't tell. Maybe there's some in-depth analysis where you could figure out that is an in-depth a zero force member. But right off the top of my head, I would say, I can't tell. Right here, I would say that definitely has some sort of force because you're going to have something to resist this, and therefore you're going to have an X component to this, and if you have an X component to this, you have to have a Y component, and therefore you will have, unless that reaction right here resists, which it doesn't say it does. So let's assume that this will also have a load on it. So we're not sure about those two. They may carry no load, but we don't know that yet. And let's just go ahead and do an analysis. Actually, before we do that, let's take a look at these possible answers. It says all of the diagonals are in tension. And looking at it, that's plausible. Maybe. Who knows? The top chord is in tension and the bottom chord is in compression. And I will say yes to this. I mean, if it's just like a simple cantilever wall or cantilever beam. You have to look at this truss as a beam. The top is going to be in tension and the bottom is going to be in compression because it's going to go like this. So I'm going to say yes to number 2. Number 2 for sure. Alright, let's see what else we can say yes to before we do any analysis whatsoever. All of the verticals are in compression. Verticals, compression. It says all. So I'm going to say no to that one. It says all, and we already know this is a zero force member. So I'm going to go ahead and say no. I don't want to say no straight up because I never like these questions. But for the most part, I'm going to say no. That's incorrect because that's not in compression. It's not in tension. It's a zero force member. So I'm going to say no to 3. That's a yes to 2 and a maybe for 1. Alright, moving on to number 4. It says all the diagonals have 0 stress. Well, we're not 100% sure about that. That's a possibility. And then it says all the verticals have 0 stress. Well, that's another possibility. So if these diagonals have 0 stress, if they end up having 0 stress, then if you look at it, if that's a 0, then you have the same situation as you do here, and that would be 0. That would be 0. Then that doesn't mean that vertical has to be 0 because you still have a reaction there. Alright, so let's go ahead and do the analysis on this. I'm assuming that this is 10 foot, 10 foot, 10 foot. Alright. And essentially, I don't know why they have all this stuff. Why couldn't you do this with just the big triangle, if you will? I don't know. I guess you could. Let's keep going. Let's do this analysis here. All right. So first thing we want to do when we look at it, we want to make a free body diagram, or we want to figure out what the reactions are. Let's take a step ahead and let's go ahead and define these joints. I'm going to call that A. I'm going to call this B. I'm going to call this C. D, E, F, and G. And that's just so we can easily define it down here. And first thing we can do is figure out what these are. I guess you don't have to. You could just go and start cutting and looking at that side, which might be the easiest way to do it, to tell you the truth. But let's go ahead and figure out for fun, since it is fun. We're going to figure this out. So F reaction Fx, let's call it, equals what? And this is going to be R G X. This is going to be reaction at G Y. And let's go ahead and figure this out. And if you look at it, you can sum the moments about this point. And I'm not going to write this down because I don't want to. Actually, I will. I'll go ahead and write it down. Why not? I'm doing this to help teach. I might as well go ahead and do it. No, I'm typically put the positive moment this way. So I'm going to say the sum of the moments, and I'm going to figure out this RFX first. So I want to get rid of these two unknowns, and I can do that by making them concurrent, and that was easy enough. So I'm going to sum the moment about joint G equals 0. I'm going to have a negative 10 kips times 30 foot, and then I'm going to have a positive RFX times 10 foot. And if we do a little quick math, well, we have negative 300 divided by 10. 10 times 30 divided by 10 foot, and you get 30. Let's see. 3, I don't remember what I said. Anyways, RFX is going to equal 30 kips. Does that make sense? Sure it does. Yeah, it makes sense. Alright, so, and we know, and the sum of the forces in the x direction equals 0. I'll hopefully go a little bit quicker. If you have 30 kips from RFX, you have a negative RGX equals 0, and therefore you know that this is going to be 30 kips as well, but that's going in the opposite direction, and that should make sense to you right away. And then this RGY is going to equal 10 kips because you have sum of forces in the y direction equals 0. You have your negative 10 kips. You have plus RGY, and you do the math, and you get positive 10 kips. All right, so there is our free body diagram with our reactions now calculated. And if you wanted to check yourself real quick, let's just do that. You could sum the moments about point A, and that would get rid of this 10 to see if you're correct. So you have 30 times 10, which is going to be 300 foot kips, and to resist that, that's going to be going in that direction, this direction. And to resist that, you're going to have 10 kips times 30 foot, which is going to be 300 foot kips in that direction. So that makes sense. You should be good. Alright, now let's continue on. And we can do a few things real quick. Let's just do the method of joints, my preferred method, because I'm just like that. Alright, so we've got point A, and I'm going to have to move on the 2 videos to get this fully where I want it, but that's okay. I want to do a sufficient job at this. So there's 10 kips. We cut point A, and we're looking at force AB and force AC. Alright, and we know that, what is the angle here? Well, it's a 3-to-1 slope, so I don't know off the top of my head what that is. So let's do a quick tangent. You have 10. If you think about it, what is this right here? This angle. That's what we're looking for. And that's going to be tangent, the inverse tangent of TOA opposite, which is going to be, well, we'll just say 10 over 30. The inverse tangent of 10 over 30. And we get 18.43. 18.43. Good enough. 18.43 degrees. And if you prefer to do ratios, that's probably an easier way to go about this than what I do. I always seem to go the hard way and go with what I know, and that's my angles. So, actually, I'll go against my trend here, and I'll do ratios. So we have a 3 to 1. This is 3, this is 1. Actually, scratch that. I'm not going to do ratios. I'm going to do what I'm used to. I'm just going to call this FABX, and this over here is FABY. But it's probably, once again, this is going to be easier if you just do ratios. And we said that this angle equals 18.43. It's actually 18.435. That'll get us a little bit better. More exact number. And then what we want to do first is we want to figure out, we want to isolate something, and we can do that by summing the forces in the y direction, because this FAC does not have a y component. And therefore you have a negative 10 kips, and you have a positive E, or FAB, in the y direction. And now you can see that FAB in the y direction is going to equal 10 kips, and it's going to be in tension. So FABY equals 10 kips tension. And from that, you also can get your FABX. And it may be hard to see it over here, so I'm going to enlarge what we have. So we have this 18.435 degrees. And we now know the y component, which is right here. And this equals what? 10 kips. Okay, so now we can figure out what the x component is of this, because we know the angle, we know the opposite, and now we can figure out what this is. And we'll use tangent again, and you want to say tangent of 18.435 degrees equals opposite over, let's call this adjacent, A. And you get, you're going to have to take 10 divided by the tangent of 18.435, and you're going to get 30. And if you're a smart person, you could have figured that out using your ratios. So as you can see, it's a 3 to 1 ratio exactly, and you could think of it as similar triangles, as you have 3 and then 1. So anyways, I'm not going to do the math here on the paper, but I'm going to say 10 squared plus 30 squared to the 0.5 is 31.6. So 6.2 kips in tension is your FAB. Oh shoot, I'll just go ahead and do it. 10 squares plus 30 squared equals 31.62 kips in tension. Alright, and I'm going to go ahead and stop there. We now have, actually, we now know that FAB equals FAC, so we can go ahead and assume that too. If you do the sum of the forces in the x direction equals 0, you will get FABX is 30 kips. That's in the positive direction, so therefore you know that FAC minus FAC, let's say, it's going to end up being plus, but then you know it's minus, so it's going to be 30 kips compression. Alright, I'll stop there and I'll pick up on the next video.